Okay.
So today's speaker is Jay Capasso. He's our agronomy agent here in Columbia County. Jay, how long have you been here in Columbia County?
Almost 2 years, about a year and a half.
Yeah, so and I'll let him kind of introduce kind of what he does here for us at this extension office. But today he's going to be talking about soil health, so we're very excited. So Jay, I will turn it over to you.
Well, thank you for having me. I've been very impressed with this program, and I think it's a great program to have at this time. You can garden while social distancing and do everything virtually. I think this program's just been great at that. So I'm Jay Capasso. I did my bachelor's at Cornell University, where I went to College of Agriculture and Life Sciences, and I worked at the Cornell Soil Health Lab when I went there. From there, I went on and I did my master's in soil and water sciences here at the University of Florida. Now I'm up in Columbia County working for Extension, and most of my growers are watermelon, field corn, and peanut growers up here in North Florida. So I think I just switched slides there. So I'm gonna do kind of an overview of soil science principles to start with in this presentation. And then from there, I'm gonna go on and kind of touch on soil health. Soil health is kind of a buzz term at the moment, and it incorporates both soil sustainability, looking at managing soil from a natural resource point of view, and also managing soil for plant health and for plant production and agricultural production. So soils provide habitat, mostly for microbes. Soils are very much still alive. And a single gram of soil or a teaspoon of rich garden soil can provide about 1 billion bacteria within that 1 gram. So that's a lot of bacteria. It can have yards worth of fungal filaments within that 1 gram of soil, scores of nematodes, and thousands of protozoa, which are little single-celled organisms. Soils are also a source of nutrients, both macro and micronutrients to plants. And soils hold water, which is really important. We don't think about that too much, but it's very important for supporting plants and supporting life. You know, different soils, like sandy soil, is not going to hold water as well as a clay soil with finer texture. So we'll talk a little bit about how soil texture kind of affects water holding capacity. And soils provide physical support, from plants to skyscrapers. So for human construction as well. About 95% of food production occurs in soils. We don't need soil to grow plants. We also have hydroponic systems, but most of the food production around the world is occurring from farming the soil. So if you were to take a soil science class, they would probably give you the Ray Wild Nature and Property of Soils textbook, and they would show you this diagram. And in this diagram, you'll see that soils is made up of water, air, mineral material, and organic matter. So starting with water and air, the amount of air, or airspace or pore space in your soil versus the amount of water is going to be dependent on whether it just rained, whether you just irrigated, whether you're going through a drought condition. So it fluctuates a bit. The mineral material of the soil has to do with the different sized mineral particles. So in soil, that's generally clay, silt, and sand, with sand being the largest size particle, followed by silt, and then clay being the smaller size particles. And then organic matter. So organic matter is basically dead organic material, maybe decomposed plants, dead animal biomass. It all gets recycled in the soil. And it's really important for providing plants nutrients and providing the biology of the soil life, a food source. It's kind of the base of the food web, which you'll see in the next slide. And it is also really important for physical health of the soil. Soils that have a lot of organic matter is less likely to be compacted. So a lot of what we talk about when we talk about soil health has to do with organic matter and increasing the amount of organic matter in our soils. One thing to note about this soil, if you're from, the northern United States, this might be a really good representation of what a typical soil looks like. However, here in Florida, 5% organic matter in our typical sandy soil is very, very high. We do have soils in Florida that form under wetland conditions that have very, very high organic matter contents. They're called histosols. They can have up to 80% or more organic matter. But those formed under special conditions. Our typical sandy soil here in Florida, we're probably more around 1% organic matter. So a lot of that has to do with the climate we have in Florida. We have a subtropical climate, which cycles organic material very quickly. And we also have very sandy soils for the most part, which have a lot of airspace, which is good for aerobic decomposition by microbes. So basically what that means is there's a lot of oxygen in the soil, which allows for a faster decomposition rates compared to if you did not have a lot of oxygen, such as in a wetland condition or in a really clay soil, a fine textured soil. So this is the soil food web. And this is a great diagram from the NRCS. You'll see at the base of the soil food web, you've got organic matter. So this kind of fuels the soil life. And bacteria and fungi, they'll feed on organic matter. Certain kinds of fungi and bacteria will be problematic and pathogenic to plants in our gardens. But many are mutualist. So they team up with our plants and provide some form of function, which I'll be discussing in the next slide. And they're also a food source for other organisms in the soil. Protozoa, for example, are single-celled organisms, and they feed on bacteria. And bacteria generally have more nitrogen in their biomass than the protozoa need. So a lot of that nitrogen gets excreted back into the soil and is taken up by plants. Fungi, they're very beneficial at providing nutrients to plants, and they help decompose organic matter. You also have your nematodes. So nematodes often get a bad rap because when we are concerned about nematodes or talking about nematodes, it's generally because we've got plant parasitic nematodes in our garden or in our crop fields. That's when we notice them because they're little microscopic roundworms. But most nematodes are actually good guys. They're not bad guys. Most nematodes help to break down organic matter. They might feed on fungi and bacteria. Some nematodes will feed on other nematodes. So most nematodes are actually good guys, but we generally don't notice nematodes in our soil unless we have a plant parasitic nematode that's really a population that's gotten out of control. So it's important to have a good, diverse soil food web because if you have that, you might be able to keep pathogenic microbes to our plants more under control. And I think the nematodes are a great example. If you have a great diversity of nematodes, you'll have a lot of predators nematode predators that will eat on other nematodes that might be parasitic to your plants. So it's good to have a good, diverse soil food web. You also have arthropods. They help to kind of shred organic matter into smaller pieces, and they're kind of varying sizes of arthropods. Then you have your larger, soil life, the gophers and birds that also exist in the soil. So nitrogen fixation. This is a great example of a mutualistic relationship between plants and microbes. So rhizobia bacteria, they form a mutualistic relationship with leguminous plants. So plants like peanuts, peas, beans, they'll form little nodules, which you should be able to see in this picture. They're little spherical shaped, and they just hang off the roots in this picture. And they're sometimes mistaken for nematode damage because nematode galling will sometimes resemble nodules a little bit, but they're generally a little bit more spherical than nematode galling. And if you break them open, if you pick them off your roots and you crush them open, you'll see a little bit of pink and purple on the inside. And that's how you know that they're nodules and that biological nitrogen fixation is indeed occurring. So this is between rhizobia bacteria and leguminous plants. And both get something in return out of this relationship. The rhizobia bacteria provide the nitrogen to the plants, and they fix that from the air. The air around us is about 78% nitrogen that we're breathing in, and it's relatively inert. Very few organisms can access it, other than a few microorganisms, and also people. We've figured out how to use a lot of energy through the Haber-Bosch process to convert nitrogen in the air to plant available forms. But the rhizobia in this relationship provide the nitrogen to the plant, and the plant in return provides carbon, compounds, sugars, and starches back to the rhizobia bacteria. One other mutualistic relationship is mycorrhizal fungi. They provide nutrients to plants. You know, their filaments can access nutrients in areas that the plant roots cannot, especially phosphorus, and they provide that to the plant. And in return, they also get you know, carbon compounds and starches in return. Another really cool, this isn't a mutualistic relationship, but you know, I found this picture so cool because this is a type of fungi that will actually eat nematodes. And it does this, I think it's called the Arthrobotrys fungi. And under low nitrogen conditions, it'll actually form these filaments that can catch nematodes. And the nematodes get trapped in them, and it becomes a source of nitrogen for mycorrhizal, or not for this type of fungi. So transitioning here away from soil biology and soil life into soil texture a little bit. So soil texture has to do with the relative proportion of clay, silt, and sand-sized particles. These are particles that are in the fine earth fraction of particles. You have particles that are bigger, you know, mineral particles that are bigger than 2 millimeters in diameter, such as gravel and then cobbles, stones, and boulders. So you can get really, really big mineral particles, obviously, that you need really heavy machinery to move. But you also have very, very small mineral particles, such as clay, kind of in the fine clay fraction over here, that you'll need a microscope to see. So you see this picture below, you'll see this is kind of a relative example of what a gravel, sand, silt, and clay-sized particle look at in proportion to one another. So with sand, everybody can see sand for the naked eye for the most part. Some of us that, you know, really eat our carrots and have good eyesight, they can see silt. Some of us can. But unless you have a microscope, none of us can see clay. Clay size, an individual clay size particle is just too small to see with the naked eye. So when we talk about soil texture, it's the relative proportion of these different clay, silt, and sand-sized particles to one another. So you can use the soil texture triangle, and you know, if you had a soil with 40% sand and 30% clay or 30% silt, then over 30% clay, you should end up about there in the clay loam fraction, or the clay, you know, clay loam sort of texture. And there are ways to do this, you know, using laboratory methods where you let particles settle in water, and they'll settle, different size particles will settle at different rates. There are more advanced methods using lasers where they will, you know, flash a laser at different particles, be able to tell its particle size, diameter. But there's also, you know, more simple methods like using your hand. For example, you might roll soil in a ball, and after you wet it down, and if you can't even roll a ball, if it doesn't even form that, it's probably a sand. And then there are more methods you can use by hand. Once we get back into in-person programming, I'm looking forward to being able to show people how to do texture by hand. But it's something that can be done, and If you're looking to do that for your soil in your backyard, you can look up online how to do that or contact me. So soil texture is a master soil variable that affects many different processes and functions of the soil and really informs different management strategies. For example, if we had a sandy soil, we're going to have a lower water holding capacity compared to a soil that's silt or predominantly clay particle sizes. You're going to have more aeration in a sand soil compared to a silt and clay soil. If you think about having a shopping cart full of basketballs compared to having a shopping cart full of golf balls or something smaller like a bouncy ball, obviously there's going to be a lot more airspace in the shopping cart between the basketballs than between the golf balls or the bouncy balls. Drainage is generally faster in coarser textured soils, like sandy soils, like we have here in Columbia County in Florida. And you're going to have slower drainage in silt and clay sized soils. Organic matter is generally lower, as I was speaking about earlier, in sandy soils compared to silt or clay soils. Organic matter decomposition rates are faster in these sandy soils and coarser soils. One great thing about our sandy soils is that they're less likely to become compacted compared to silt-sized particles or clay-sized particles. If you think about it, they're just bigger, and particles that are silt-sized or clay-sized, they have a lot more surface area, and they can really be compacted. These particles can be compacted together a lot easier compared to sandy soils. Interestingly, when it comes to wind erosion and water erosion, silt-sized particles can be eroded very easily compared to clay and sand-sized particles. Shrink swell potential, depending where you live, you might see this in certain kind of clay particles, and that's kind of when a soil is wetted, it kind of expands, and then it retracts after it dries. So you might see different cracks on the soil surface, after a rain event and then after it dried out. That is especially true of clay soils with Montramillerite clay minerals and smectite minerals. So then when it comes to thinking about sealing of ponds, dams, and landfills, obviously sand, which has very good drainage, it's probably not a good idea. Water is gonna infiltrate through. But when it comes to clay, silt's a little bit better than sand, but when it comes to clay, it's a much better at sealing for ponds and dams and landfills. The suitability of tillage after rain, if you're going to disturb the soil, whether you're using tillage equipment or a hoe, whatever you're doing, it's easier to do that for a sandy soil, which has better drainage compared to a silt and a clay soil. Pollutant leaching potential is higher in a sand soil, as you can imagine. There's better drainage, so water kind of flows right through along with the pollutants or the nutrient ions. So often our sandy soils will leach our fertilizers very quickly, unfortunately. And then when it comes to resistance to pH change, clay-sized particles, which have, there's so many more little particles in there, so they have more surface area around them. They have a lot higher resistance to pH change compared to silt and sand-sized particles. So when we're thinking about soil health, soils that have a lot of organic matter, they're able to resist compaction, but they're also able to really suck up a lot of water. So that's one of the physical benefits of increasing organic matter in our soils. According to the USDA and NRCS, Every 1% increase in organic matter in our soil leads to 20,000 gallons of available soil per acre. So this is beneficial if we're in a drought condition. Our soils can hold water longer for our plants, but it's also maybe beneficial in flooding conditions where our soil can hold more. So a soil that is undisturbed looks like that perfect soil that I showed you earlier. You know, something between 20 and 30% air and water, and then your 5% organic matter, and your 45% mineral material. But when you get to a compacted soil, you have less airspace for, you know, for pores, for water, for air, and then you have less space for organic material as well. So, and that can restrict plant growth. Sometimes plant roots can't grow through a compacted soil, so it can be very problematic. So when it comes to soil health and the chemistry side of you know, soil science, we've often traditionally looked at soils through the input-output model. So you put on a pound of fertilizer and you hope to get you know, you put on a pound of nitrogen, you hope to get another bushel per acre of corn. But that doesn't really take into account the different nutrient cycling systems that exist in our gardens and that can exist in our crop fields. So, you know, if we use things like cover crops, if we try to reduce the amount of disturbance to our soils, we're probably going to be able to hold more nutrients in our soil and more organic matter and cycle those nutrients. So the main nutrients in soil we've got are macronutrients. Those consist of nitrogen, phosphorus, potassium, calcium, magnesium, and sulfur. And then you also have your micronutrients. So chlorine, iron, boron, manganese, zinc, copper, and molybdenum, and nickel. And you see the diagram over here, you see the nitrogen cycle, and you see how complex it is, but we do have the capacity to recycle nutrients like nitrogen in our soils. So pH, soil pH is something that definitely affects nutrient availability. In most crops, we want to have a soil pH around 6.5. But you know, for certain plants and certain crops, we might want a more acidic pH. I think azaleas like more acidic pH, blueberries like more acidic pH. They might want to be somewhere around 5 and 5.5. But for most of our plants, shooting for somewhere around 6.5 is ideal because it's ideal for our macronutrients that you see on top here. And if you keep going further down at the 6.5 line, you'll see it's good for many of our micronutrients as well. See, the high pH can be problematic for many of our micronutrients, while the low pH can be problematic for many of our macronutrients. Another thing to consider in your garden is the mobile and fixed nutrients. So most of our mobile nutrients, these are nutrients that will move in our plant from older growth to newer growth if it's needed. These consist of the macronutrients mostly, the nitrogen, phosphorus, potassium, sulfur, and magnesium. Calcium is a macronutrient that's a fixed nutrient that doesn't move in the plant, but most of our mobile nutrients are macronutrients. So these nutrients move in the plant from older leaves to newer leaves. And you'll see the nutrient deficiencies occur in the older leaves. So this is a picture from one of my smaller growers here in Columbia County of a citrus tree, of a lime tree. And this is a magnesium deficiency. And you see that it's in the older leaves, the leaves you know, just above the ground. And that magnesium must have been moved from the older growth to the newer growth on top of the tree. Then you have your fixed nutrients, and these do not move in the plant. So you'd see these in the new growth or the younger leaves. So you can get good at you know, being able to tell which nutrient deficiencies you're seeing in your garden. They'll vary a bit depending on which nutrient is deficient and also your plant that you're growing. Phosphorus, for example, often you'll see kind of like a purplish color in many plants when it's phosphorus deficient. But if you think you have a nutrient deficiency, I recommend either contacting your extension office or looking online and seeing if you can find that kind of nutrient deficiency on Google and see if it looks the same. So Liebergs Law of the minimum. This is a soil science concept that's been around for a very long time. And it has to do with, you're only as good as your most limiting nutrient. So in this case, it looks like they don't have enough phosphate, enough phosphorus. So that's their yield that's falling out of the bucket. If we had a little bit more phosphorus, maybe it would be nitrogen that was then limiting yield or limiting plant growth. So it's an important concept, and I don't think it only needs to be applied to nutrients. I mean, this might be something to think about if you've got a tree in your backyard that's blocking sunlight to many of your plants. Maybe your plant's not getting enough sunlight, and that's the problem. Just a useful concept that's been around for a very long time. So one problem that we've run into when it comes to fertilizer and applying nutrients to our gardens or our crop fields has been runoff. We use nitrogen fertilizer and we often use phosphorus fertilizer. And nitrogen is the limiting nutrient in saltwater bodies when it comes to algal growth. And phosphorus is a limiting nutrient generally in freshwater bodies. So we've seen this be very problematic, especially in South Florida, when we have more nutrients in the water and just their algal growth and blooms that occur. So agriculture and gardening isn't the only thing that that contributes to this. There's also septic tanks and how we fertilize our lawns. We all play a role in this. But it's just one downside of, applying a lot of nutrients to your land. But I think soil health is a, great concept because you're thinking about your soil holistically. And if you're really taking into account soil health practices, you might be trying to recycle some of those nutrients. So I think soil health and considering your soil's health will be beneficial when it comes to combating some of these issues like eutrophication and algal blooms. So I'm going to get to the definition of soil health now by the Natural Resource and Conservation Service, the NRCS. That's a part of the US Department of Agriculture that was formed after the Dust Bowl back in the 1930s. But they define soil health as soil health, also referred to as soil quality, is defined as the continued capacity of a soil to function as a vital living ecosystem that sustains plants, animals, and humans. And I think the big part of this definition is the continued capacity of the soil to function, to meet the needs of what you are trying to do. Soil is a really important natural resource, and increasing the amount of organic matter is generally, when it comes to storing more carbon in our soil, or managing our soil for crop production or plant production, is generally very beneficial to long-term sustainability of our farming systems and environment. So when it comes to building soil organic matter, there are many different practices. You can apply soil amendments such as peats, biosolids, manure, compost, and wood products. Cover crops are also a great practice. It's really important to keep soil covered to prevent erosion, and it also helps to contribute organic material to the soil. Mulching is another great practice, especially in gardens. And reducing the amount of soil disturbance is also very important. Whether you're using tillage equipment or whether you're using a hoe in your garden, the more disturbance you have of the soil, probably the faster the decomposition rate of your soil organic matter. So you're allowing oxygen into the soil, but you're also breaking your organic material into smaller pieces, which leads to just faster organic matter decomposition rates. It's also important to leave crop residues when you can, because they're another source of organic matter to soils. One problem we've gotten into is that we're really good at being able to take care of the nutrition of our plants nowadays with fertilizer, but we're not often applying organic materials back to the soil like we used to. Back in the day, they used to fight wars over guano, which is bat poop down in South America. Before the Haber-Bosch process, they started being able to do synthetic fertilizer over in Europe. But one downside to this is that we're depleting the amount of organic material in our soils when we only apply nitrogen. The nitrogen of the fertilizer, it feeds the plant, but it doesn't necessarily feed the soil. And we get more benefits from soil organic matter than just nutrients. We also get physical benefits. We'll be more resistant to compaction. We'll be able to hold water better, and soil biology benefits of maybe having a more diverse soil food web to take care of problematic organisms or pathogenic organisms to our plants. So tillage and soil disruption. There are a lot of pros and cons to tillage. The pros, you kind of incorporate amendments if you're applying manure or compost to your field, tilling it in or hoeing it in, or whatever practices you're using is good for incorporating those amendments, which can help to build organic matter in the long term. It's good for weed control. It kind of levels out the soil. It creates a good seed bed. But the cons are that you get increased erosion. You reduce your soil quality over time because you're degrading the amount of organic matter in your soil. You can cause soil compaction issues. Often around 12 inches in cropping systems, you start to see a plow layer that kind of develops. It's kind of a compacted layer, kind of where the plow hits the bottom of where the soil hits the bottom of the plow. And it also disturbs soil life. So you might be destroying some beneficial life forms in the soil. So there are obviously a lot of benefits to tillage, but you should also keep in mind that when you do disturb your soil a lot, you might be degrading the amount of organic matter that's in your soil. So I'm not saying that you should go out and get rid of your tillage equipment or your hoe or whatnot, but just I would incorporate that in your mindset when you think about managing your garden or your crop field. So yeah, going on, obviously when you manage for soil health, you're managing for the biological characteristics of your soil, the chemical, and the physical. That's kind of where it all comes together, is when you're thinking about all three of those aspects of your soil. When I used to work at the Cornell Soil Health Lab, what we would often see, we'd get soils that came in from New York or Pennsylvania, and we would see that the physical health of our soils, we had different tests that could test the physical health, would be pretty poor. The biological health of our soil would be fairly degraded, but then that we'd have a perfect chemical health. We had perfect pH here. We had good extractable phosphorus, potassium, good minor elements. So we've gotten very good at managing our soil fertility. However, we also need to think about the biological health of our soil and the physical health of our soil. So these are the different soil orders of Florida. So we've got 7 of the 12 soil orders here in Florida. And the ones we don't have, such as andisols, they form under volcanic conditions. Gelisols, which form under permafrost, so very cold conditions. We do not have iridosols, which are desert conditions, or oxasols, which are heavily weathered, then they form under tropical rainforest conditions. But we have many different kinds of soil. I think if I was to overly generalize Florida soils, I would say that we have, very sandy soils in much of our state. You get down towards Belglade, which is a big sugarcane producing region where I did a lot of my master's research. There's a lot of histosols there because that area was drained from the original northern Everglades. So those formed under wetland conditions. But nowadays, now that they're under aerobic conditions, the soil is depleting all the time. And I don't think I touched on this earlier, but this is a great picture here of the subsidence post in Belglade. You can see where the soil level or the ground level was in 1924. And then you go all the way down to where it's at today. And this post is, I'm not very tall, but this post is taller than I am now. So there's been a lot of soil subsidence that's occurred from opening up these soils to more aerobic conditions, or conditions that have more oxygen than in a wetland condition. We also, down in the Homestead area, have soils that have a lot of calcium carbonate, where they're basically like farming on crushed lime rock. So areas of South Florida will have a lot of calcium carbonate in them, and that can lead to really high soil pHs in some cases. Over in the Panhandle, our soils tend to be a little bit heavier. They have a little bit more clay content compared to where we're at here in Columbia County and northern central Florida. The soil orders are useful, but I think if I was to, make a recommendation for somebody on how to manage their soil, I'd want to know about their soil texture and their, their nutrient or soil test. Some testing that's gone further that considers the biological indicators of the soil, the physical indicators, and the chemical indicators are soil health tests. So at Cornell, we had the comprehensive assessment of soil health. And that was the test you saw earlier here, where we had many different tests of soil quality. The NRCS also will sell, different kinds of soil test kits where you can test the quality of your soil for both the biological, physical, and chemical out in the field. Waters Agricultural Laboratory, they're up in Georgia. They're beginning to do soil health tests. Ward's Laboratory, which I believe is in Nebraska, they've been doing soil health tests. I think they're the private lab that's been doing it the longest. And there's also this extension article here, which I co-authored, which you're welcome to look up if you're interested in different tools for evaluating your soil quality in your yard. This is an example of IFAS Extension Soil Testing Laboratory. So generally, we kind of have a standard soil fertility test, but you can get an organic matter, percent organic matter content done as well. That's for an extra $10. In Florida, we kind of get away with really looking at the nutrient or the chemical side of our soils because we don't deal with the same compaction issues with our sandy soils compared to other places. But it's still important to look at the physical and biological side of things as well. These are some different physical soil health tests, such as available water holding capacity. They use pressure chambers to just try to figure out how much water your soil is holding. And they try to figure what the difference between field capacity, which is the amount of water your soil can hold against gravity, versus the wilting point, which is basically where your plants are dying, where there's no more water in the soil. You get surface hardness. You can measure compaction with a penetrometer. You push it into the top 6 inches of the soil, and it basically just measures how much resistance the penetrometer comes across. You do that for subsurface hardness using a penetrometer. You just use it at a deeper depth. Aggregate stability is also a great way to really test the physical health of your soil. And it tests on how well your soil aggregates or how well your soil withstands a rain event or a disturbance event. The chemical soil health tests are basically what you get in a typical soil fertility lab. They're probably going to look at things like macro, micronutrients, the pH of your soil. They might look at electrical conductivity, which is a measure of the salinity in your soil. A soil health test might go even further and look at what kind of heavy metals are in your soil that could damage human or plant health. That's only if you're being very comprehensive, or if you have a reason to suspect that there could be heavy metals in your soil. And then biological soil health tests include organic matter. They put soils in a furnace at 500 degrees Celsius. They weigh the mass before and after to see how much organic material is in the soil. So after you burn off that organic material, it's kind of the mineral material that's left. And that's how you can tell, what percent organic matter your soil has. You can look, it can be really simple. You kind of just look around and, measure the amount of earthworms that are in your soil. They're generally indicative of soil health. Here in Florida, many earthworms are actually invasive, but, they're very good at incorporating organic matter into our soils. And they also cycle organic matter very quickly. Soil respiration in some labs will actually measure the amount of carbon dioxide that's coming off of the soil, which is a useful indicator of the soil's biological activity, because microbes, they're breathing off CO2, and it's just useful to measure how much activity is going on in the soil. Then you have your active carbon. They use a solution, potassium permanganate, to try to measure what part of the organic matter is easily available to microbes. What part is labile or what part can be easily mineralized. And it's usually measured by quantifying the amount of potassium permanganate oxidation, which is basically a little solution that turns purple. And the more purple it turns, the more active carbon you have. But it doesn't have to be that complicated. So you can go out in your yard and really get an idea of, your soil health or your soil quality. You can, look at the color of the soil. A soil that's darker probably has more organic matter. You can smell the soil. Healthy soil is a very earthy smell. That's actually the smell of actinomycetes. You sometimes smell them after it rains, but they're a kind of bacteria. So if you smell a very earthy smell, that's probably a good sign. The presence of biological activity, whether you have earthworms, whether you have, other forms of life in the soil, and just the feel of the soil. You could simply poke, a thing of soil to see if it's compacted or not, or if your finger just easily moves through it. So in conclusion, soil is alive, supports many different organisms, from microbes, bacteria, to fungi, to viruses, to larger animals such as gophers. Soil texture is a master variable that informs soil management practices. It really informs how you should manage your soil. Managing for soil health considers taking into account the biological, chemical, and physical characteristics of a soil. And when it comes to soil health testing, it's a more comprehensive form of testing that looks at the biological and physical side of things, not just the chemical side of things. And this is a picture here of all my plants that are out on my balcony. I just live in an apartment, so we just have them out on the balcony. But since COVID-19 and everything started, we've definitely increased the amount of plants that we have. So that's the picture of my garden. But yeah, if you guys have any questions.
If you have any questions, can you put them in the chat for us? I did put the tools for the soil health evaluation that you had, Jay, the EDIS publication. I did put the link up there for you.
Okay, awesome.
Yeah, so if you have questions, let's put those in the chat. I think this was an interesting talk, especially where the part where you're talking about feeding. We're really good at feeding our plants. We've gotten really good at fertilizing them, but I think feeding the soil, people are, and then this group is likely pretty good at it, but it's maybe not something that we think about as much, or we need to get back to.
Yeah, and you just get certain benefits out of increasing organic matter that have nothing to do with nutrients too.
So most of us are dealing with pretty poor soils. um, very low organic matter, maybe 0.5%, 1 if we're lucky. The pH is not usually horrible. And I know when we had Dr. Treadwell on, she had suggested like put mulching with hay, basically, like bahia hay or something like that that's been untreated. What would you say your favorite method of improving soil organic matter would be? Would it be mulching? Is it cover crops? What do you think for us would be the easiest or the best?
I think amendments are a quick way to do it. Whether it's compost or manure, buying potting soil. That is one thing in the garden realm of things, that you're often buying potting soil to plant things in. So you are increasing the amount of organic matter in your soil. You're not just applying fertilizer versus, if you have a big crop field, you're not applying potting soil to it. So I think amendments is probably the quickest way to do it. But for long-term sustainability and I think really minimizing the amount of disturbance, you're going to need to disturb your soil every once in a while to control weeds or create a seed bed. But I really recommend being conscious about when you do that, and just knowing that you're oxidizing organic matter when you do that.
Yeah, I think that's a really good point. We had talked about that during the pest talk as well, how a lot of our pollinators, our native pollinators, are ground dwelling. So every time you disturb that soil, you're also disturbing all your pollinators and your organisms that are there as well. So anybody have any questions? I don't see any in the chat, so I think you're pretty thorough.
Should I be able to see the chat?
You can, if you go down to the bottom, there should be a little bar that says chat.
Okay.
You can see it there. Everybody find it?
Let's see.
Okay.
I can't find it, but that's okay.
Okay. Well, if there's no questions, you can certainly contact our office if you have questions later. I know Maxine's still doing soil testing still. We're opening soil testing here at our office in Columbia County probably next week. So that'll come back online for anybody that's needing that. We do the free pH soil testing. You'll be able to just drop it at the office and we'll do it for you. I don't know if Alachua County is still doing theirs, but you'd have to call their office and double check. But I know, like I said, Marion County certainly is, and we're picking it back up here in Columbia next week. So, and then if nobody else has any questions, I will say thank you, Jay. We really, really appreciate you coming on. And Marion said thank you. And we'll see you guys next week.
Well, thank you all for having me.